And we are live. Welcome, Danny Diaz. We're very excited to learn a little bit about the React framework from you. Uh, for the people listening in the crowd, Danny Diaz is a data and AI engineer at Banco Pichincha. He has developed a chatbot using generative AI and other machine learning techniques to support personalized customer experiences. So, with that, Danny, the floor is all yours.
Thanks, Joaquin. So I will be talking about in this presentation about how we go harnessing generative AI using a graph of LLMs. We in today's presentation, I will be focused on evolving chatbots into more advanced human-like systems and how to leverage generative AI. In order to achieve this, we must control a big problem into Gen AI that I will reveal you later. I will be talking mainly about semi-autonomous agents and the problems and solutions I found with my team at Backup Exchange. So I'm Danny Diaz. I'm an AI engineer at a relatively large bank in Ecuador, passionate about AI's potential to learn, adapt, and improve process into the enterprise. I authored a couple of papers. Maybe the most relevant is this one: development of hand gesture recognition model using deep reinforcement learning. And I will discuss a couple of advanced techniques to transform our chatbots with large language models into a system capable of behaving like a human would. So, large language models are often confined to text based tasks, limiting their potentials. To unlock their full capabilities, we must bridge the gap between text and other modalities, enabling large language model to understand and generate image, sounds, and even actions in the real world from the systems. And teams keep spacing, but companies still need a powerful chatbot with many capabilities. And we continue creating chatbots because they offer significant benefits across various domains. And the evolution of artificial intelligence has reached a pivotal moment with the advent of large language models. And despite their impressive capabilities, large language models still face significant challenge in truly understanding and interacting with the world as humans do. So today, now I will present the strategy we developed to create a cognitive assistant that can artificially uh, reasons independently and adapt to various situations, much like a human would. And we developed this strategy in the financial sector, but I will present it here in a generalized manner. So first of all, let's think in graphs. But before that, I will give you an introduction to the context why we need to think in graphs. First of all, usually we don't use one prompt to solve everything. We used to combine the output of one output. We combine one output of one large language model that handled a prompt into another large language model or into the same large language model as input to produce a new output. So this chain of prompts involve using multiple linked prompts in sequence to achieve a more complex tasks or solve a multifaceted problem. This mainly break down the task, divide the main task into smaller, manageable subtasks, And if you don't use a chain of prompts for complex tasks, several issues may arise. First of all, incomplete response. A single prompt may not capture all necessary details, leading to an incomplete or shallow response. Maybe we overwhelming complexity. Trying to address a multifaceted problem in one prompt can be overwhelming and result in an unorganized or confusing output. We also get a lack of focus. Without breaking down the task, the response may lack focus and miss important aspects. And we reduce the accuracy. So we want to combine this prompt template plus the large language model to generate an output and use that output to generate another new output. So we resolve the problem step by step. That this context is very important for the next slides. And why we should use a graph? Well, a graph is a visual representation of connections between objects, and it consists of two or more nodes, which represents objects, and we have edges which show the connections. And we can use a graph to control the flow of chains and create a system that handles multiple scenarios. And usually, I talked before about a big problem in generative AI. This big problem is control. And yes, we can modify the temperature to zero in order to not create a creative response. Maybe we could reduce the top key or the top P in order to make a response more coherent. But even with this little fine tuning, well, not fine at all, even with this tuning, we can't control the generative AI. So the idea of using some chains, some graph, is to control the output of the previous large language model. And I have another large language model that act as huge and produce a new output or correct the first output. This is the mainly use of a graph, so to give more control to the large language model system. With this background, I would like to talk about our journey to create semi-autonomous agents to react within a system. And I talked to you about nodes, graphs. So a graph have a lot of nodes, and one of these nodes could be a large language model, but also one of these nodes could be an agent. And an agent looks like this in a high level point of view. We have a large language model with an output. The output could be an action over an environment, and the environment returns an observation. And with this observation, the large language model could loop infinitely, interacting with the environment. Now, even more, this node into this graph could be an agent that artificially reasons, and this agent will have some components in order to get perception of the world. Uh, it could be through image, sound, text, and using this perception, we could produce an action, maybe using the a React prompt or maybe using a traditional machine learning technique. So we could interact with the environment with this action and get the observation. Another lower level diagram of this could be this diagram where the agent has memory, has tools, has a planning algorithm, and has actions. So the agent has a lot of tools. In this case, we have a calendar, calculator, code interpreter, search, and more. Memory could be the chat history, as simple as that. The planning is made through prompt engineering in this case. So with every component in this diagram, we have the receipt to perform an artificial reasoning. So artificial reasoning can a bot reason? Well, not, but in large language model we could simulate that with a lot of chains that I talked to you before. And in this loop of chains, we have first of all a thought. The thought is produced by the large language model. In this thought, using this thought, we could invoke one of the actions or tools that we have prepared to the agent, like the calendar, calculator, code interpreter, and invoking these tools, these functions, we could get the observation, and we will repeat the loop until we get a final answer. This way, we could apply. This is called the prompt engineering React. Of course, is reason plus act, where we let the large language model to reason by itself, acting by itself in a limited tools group of tools, and we have a lot of actions, but the final action is what breaks the loop. With this React prompt, my team solved the we my team produced an agent that could take and handle multiple decisions by itself, like here's the input, so you have to reason where you should go or where you should use. Maybe you have not to perform rack. Maybe you just have to invoke some calculator. Maybe you have to invoke some code interpreter or perform an SQL into a database. So we are routing the decisions. We are letting the agent to route the decisions by itself and perform these actions over the environment. And one agent is good, but many agents could give us a lot of control, even more control, like the chains or the graphs. So in this graph, we start from the node underscore start underscore, where the process begin uh, with the user input. We have a supervisor where the input is directed to the supervisor, which determines the appropriate agent based on the user request. We have the agents. So the supervisor by itself could be a chain. A simple chain could be another agent, or even a complex graph. So the idea is we have some agents in the bottom, and the supervisor can activate one of the four agents. So we have the first agent, the researcher, who conducts online search using tools like online search tools, maybe RAG, maybe SERP API. We have another agent, the weather, which handles weather that data, search using tools like weather data search. We have another agent, which is the coder, which writes Python code, probably using this tool, Python rep tool. And we have another agent called calculator, which performs math calculations using tools like math calculation or some large language model specialized in math. In this system, we have more control. We have a supervisor who will run this loop with this graph loop until the task end. Maybe the user want to research about something and also want to get the actual weather of some country. So the supervisor will call first to research to get the information, the first information that the user requested, and the researcher returns that information to the supervisor. The supervisor uh, artificial artificial artificially reasons if the task was complete. If the task wasn't complete, then the supervisor returns the feedback to the researcher and maybe communicates to the weather app. And then these two agents returns a new answer to the supervisor. The supervisor has a chat history, so it could monitor if the total problem was solved, and if it wasn't solved, maybe invoke another agent. So we run the this graph loop until the supervisor tells that the problem was solved. This is very important. This is very interesting too, because we don't have control over generative AI, and if we only use a prompt, maybe the output is not the desired output. And even if we use a chain of prompts, maybe the second prompt just ruined the result of the first prompt output. So in using graphs and using agents that could reason by itself in a loop, we could handle and control a lot the system. With these learnings and with these implementations, my team created the perfect chatbot for customer support and hyper personalization. Hyper personalization, it's an interesting topic in my organization, because we found that image and sound generations humanize the interaction, making AI experience more engaging and realistic. By simulating these human-like interactions, AI can bridge the gap between human and machine communication, providing context and even emotional depth. So for business, this leads to better customer engagement and satisfaction, allowing for personalized and dynamic content. Integrating generative AI for image and sounds I think, is crucial for creating these natural and effective AI systems that resonate with users. And another part of this perfect chatbot is the multimodality. Don't forget about multimodality. In our case, we receive everything as text, so we perform transformations to other types of information along the way. If we receive an image, we transform the image to text. If we receive a sound, we transform the sound to text. So our connecting point is the text. But recently, for image, we used Cloud 3 to send a prompt to that model along with the image in base 64. Finally, we created this graph, this high level graph. The perfect chatbot doesn't exist, but we could approximate something good, creating a very complex a very complex graph involving some large language model in one part, some agents in another part, and don't forget the guardrails. So in this case, for image generation, we tried incorporating it into campaigns and email personalization, but due to if an error occurs in that automatic generation, it could cause significant reputational damage to the company. So we did not pursue it further. Actually, we're only using the sound generation. We tested open source models and providers, and although Stable Diffusion allowed us a lot of customization, DALI ended up being the most effective in terms of cost and processing time. That is a very critical part in this customer experience, and therefore we abandoned the open source approach. And a similar situation occurred with sound generation. So in this, I will explain a little more about this chart, this graph. We have a user give us an input. This input pass through a word rail that handles that the input is inside the defined topic by the enterprise. If we have this solution for human resource, maybe a political question, it's not something that our autonomous system show show answer. And when the word rail of topic identifies a topic that is it's not inside a list that we define, we just ignore the input of the user and we send a static message that I can help you with that. Sorry for that. If we are in the range of the topics in the defined topics, we call another chain that had a prompt to check if the human want to talk to another human. Maybe the human want to don't want to talk with a chatbot. So if this chain returns that the user want a human to talk to, we also ignore the input of the user and we perform some actions internally to put an agent in front of the client. We have another chain, so we have a lot of filters before executing the actual autonomous agent. uh, if the user don't need a human, then we pass that input to an intent classifier. Actually, we tested an intent classifier created using traditional machine learning and another using large language model. Uh, we found that the best results was produced by ensembling these two models. First of all, the machine learning solution, and ensembling this with the output of the intent classifier. Also, another model in order to have three models. So we could put these three models to vote in order to select the most probably intent. So if two of these three models says that is intent one, intent two, or intent three, we redirect the flow to that intent. What have that intents? Depending on the situation, an intent will have specific chains, specific functions. Maybe just execute one operation into the account of the user, or get some information. So we don't have a complex artificial intelligence to artificially reason and select an action. But if the intent is the default, we invoke an autonomous agent with a lot of tools related to the bank corpus. Maybe the user want to get the balance into one of their accounts. So this agent will invoke the function that retrieves the balance of this user. But maybe that wasn't an intent that we put in the previous parts. And the idea is that the agent will call itself until as much as possible until the agent reach the final answer. Maybe the text must be converted into audio. Maybe the text along must be with an image. So the agent will generate everything necessary, and then the agent will output to another wild rail that will take care about the ethics and safety about the constitutional of the enterprise, and finally returns the final answer to the user with image or the answer as sound or text to speech. Finally, I would like to share with you the lessons learned by my team. First of all, open source models give us total flexibility, but only very few use case Need need it. Sorry. We went back to a provider for overall speed and accuracy. So we also another lesson is fine tuning should be the last resort. Generally, prompt engineering and React solve most use case. Another lesson learned from this is that large language models that can make decisions on their own using React are very useful, but they sometimes fail. And in this case, it's better to use hard rules or traditional artificial intelligence to perform these decisions in a more deterministical manner. And and finally, you should consider a continuous improvement flywheel that I would like to talk in another sessions. So that's all for my presentations. And thanks. If you have some question, I would like to read it.
Thank you, Danny. Yeah, I find that explicit model of the React framework to be really interesting. I think, like you said, one key takeaway is how do you develop a deterministic model around the use case? I mean, you encountered that problem with the open source LLMs not being sufficient in quality or exactitude for the personalized experience that you want to deliver for customers. But maybe if it had a little bit more of a structured approach or some rules that help guide it, it can perform better. What do you think?
Yes. When we use a large language model, we have a probability that the large language model give us a correct answer or a wrong answer. And if we combine multiple models, we fall into a codependency of models, which will multiply their probability that the answer will be good, and we will reduce the total system accuracy. So in order to perform, it's impossible to perform a deterministic solution. But we found in our team that if we have these wild rails to control the previous output and we perform a loop, we could have better results. Uh, but an important part is that these large language models are from different providers, because if we use Cloud 3 to control Cloud 3, you will perform even more errors. But if you use GPT-4 to control the output of Cloud 3, maybe you have a huge more fair in that.
Last question: what is the next experiment you're gonna run, maybe in the future?
We are working on video generation to campaigns. So we're working actually manually with Dream Machine. And another important part is the large language model operation. So we found that evaluating the output of the models and determine that it's a good output or not involves a lot of human review. We are actually using large language model as huge, so the same large language model huge the how much in a scale of 1 to 100 how much the output is factually correct comparing to the original or desired output.
And then this is just right now gonna augment internal marketing capabilities, but not gonna be something that you replace altogether, right?
Mm, exactly. The transition must be step by step.
Well, thank you very much, Danny, and we're gonna take a short break, and then we're gonna get on with the next presentation. It's one that's gonna make you concerned for your next speeding ticket. So yeah, we'll look forward to seeing you. See you soon.